Alright guys, I'm going to scroll up here and we'll get started on our lovely section 3.4, part 3, our final example. This is going to be a quicker part video. It is a nice short one. We're going to talk about some economic aspects, some costs, profits, revenues, and ideas like that, and their marginal costs, marginal profits, marginal revenues, and all that fun stuff. So let's first get some definitions out of there. If C of X is our cost of producing X items, is the cost of producing X items or units, then the marginal cost is MC of X, which is just equal to C prime of X, right? So it's just the derivative. Similarly, if R of X is the revenue obtained from selling X items, from selling X items or units, then the marginal revenue is MR of X, which is just R prime of X. Okay. Now, to figure out your profit, right? If C is how much it costs to make the items, and R is how much you made by selling those items, then your profit is simply the amount you made minus how much you spent. So if P of X, which is equal to R of X minus C of X, so our revenue minus the cost, is the profit obtained from, say, making and selling X units, and the marginal profit is MP of X, which is equal to P prime of X, which is equal to the marginal revenue of X minus the marginal cost of X, which is equal to just R prime of X minus C prime of X. So when you're dealing with problems, especially in this class, if you just see marginal blank, just note that's the first derivative. Easy enough. Okay, I don't want to get too complicated or complex with this situation. We just want to be nice and simple. So let's do one problem, and then that's going to be it. We're just going to do one and done. This is going to be nice and easy. So if the number of dinners that can be sold X at a price little p is given by the equation little p of X equals 9 minus 0.03x for 0 less than or equal to x less than or equal to 300. Okay, now notice this little p is not the same as big P for profit. So this is not our profit function here. So this is basically just saying like how much you can charge depending on how many meals you make. So not R, because we're not saying this is our restaurant. We'll just say the revenue in good old US dollars. So the revenue in dollars made by selling X dinners is R of X, which is just equal to X times P of X, which is equal to X times 9 minus 0.03X. So we get 9X minus 0.03X squared. Okay, again, this is still for 0 less than or equal to X less than or equal to 300. Now you may ask why is there these limits on it. It just depends on the kind of situations of the problem. So let's use the marginal revenue to estimate the revenue of the 101st dinner. So first we need to find the marginal revenue. So the marginal revenue is just the derivative of the revenue function. So we're just going to use our simple polynomial rule. So we have 9x, so that just gives us 9. Then we have negative 0.03x squared, so we bring the 2 down, so we get 0.06x, bring the exponent down 1, so 2 down 1 to 1. So there's our marginal revenue. Because we're looking at selling the 101st, how much we would make, we want to use, very simply, R prime of 100, okay, to approximate R of 101 minus R of 100. Now, the reason why we are doing this R of 101 minus R of 100 is because it wants to know what's the revenue of the 101st dinner, right? Not of up through of all 101, just that 101st. So we need to take the total revenue for the 101st, all 101, subtract the revenue for the first 100, and we're good. The reason we're going to use R prime of 100 to make this estimate is similar to what we did in part 2 using that estimate idea. So first, R prime of 100 equals, we do a little calculator work here, and we get 3. Nice and easy. Sorry. So, very simply, the approximate revenue revenue of the 101st dinner was $3. We can get exactly what this is because we know what the R function is. So R of 101 minus R of 100 is, if we just look at our revenue function, it's 9x minus 0.03x squared. So we get 9 times 101 minus 0.03 times 101 squared minus 9 times 100 minus 0.03 times 100 squared. And doing some calculator work, we get that that is 2.97. So pretty close to our estimate, right? Not bad. So that's how you can use marginal revenue. I don't want to try to get into like the really fine details of how this works, how that kind of goes about. But basically the reasoning is that the difference between 101 and 100 is 1. So kind of if we find r prime at 100, and we say, okay, if I increase by 1, right, think about r prime of 100 is our instantaneous rate of change, right? Rate of change is kind of like slope, rise over run. So if we go over 1, we're going to go up 3. So that means to go from 100 up to 101, we increase by 3. And that's how that estimate works. So that's it, guys. That's it for this section. On to 3.5, on to bigger and not just better things, but other things. So I'll see you guys there in 3.5.